welcome to Solve with Danny, and today we are going to solve some real-life exponential growth and decay word application problems, and this is part 1, so stay tuned for the other parts because then we'll do some even more problems, all right? So one strategy I really like to use with word problems is this little acronym called CUBE. So you may want to write this down, take a screenshot. Okay, but it's how I keep in mind that I'm not forgetting any pieces of information. So I like to circle numbers. I like to underline the question. I like to box in the action words, evaluate and solve and check when necessary. Okay, because it's kind of like things like, does my answer make sense? All right. And especially, I'm just going to put a little star next to underline the question, because I gotta tell you, I see a lot of mistakes with students in Algebra 1 and in geometry, like not actually answering the question the problem's asking. And a simple thing as underlining the question would have solved all their issues, okay? So let's dive in to a real life math problem, because exponential growth and decay, lots of real world stuff going on. Okay, so you invest $25,000 in an account that gets 12% annual interest compounded quarterly. How much would you have in 10 years? All right, lots of stuff happening here. Key numbers, we got $25,000 we're starting with. 12% annual interest. Annual means every year. Compounded quarterly. That could be a number or an action word because quarterly is 4 times a year. Okay. So we got to figure out how much are we going to have. So we're dealing with exponential functions. So we're dealing with those y equals a times b to the x. So let's break apart those pieces, okay? A is your initial investment. That's that $25,000. This is your A value. That's what we're starting with. Okay, so now B, that is going to be your growth or decay. Well, if you're investing money, one would hope that you're gaining more money over time. The point of an investment is to make some money, okay? But we got a little bit part we got to be careful here. There's 12%, but it's also compounded quarterly, okay? So to figure out that growth rate, we're going to take that 12%. I'm going to turn that into a decimal. And since it's happening quarterly means 4 times a year, just like you have 4 quarters, at the school year. We're going to divide that by the quarterly. We just punch that in our calculator to get 0.03. Now, 0.03 is not the B value because we're growing, right? And for it to be growth, B has to be greater than 1. So see my graphing video for a little bit more detail on that. But if it's growth, B has to be greater than 1. If something's decay, it's less than 1, but greater than 0. So to find B, it's going to be 1 plus 0.03. Oop, don't look at that next question yet. Look away, look away. All right, so B is 1.03. All right, so let's put this all together now. All right. We have y equals 25,000. Ooh, big money. Times 1.03 to the x. All right, that's our equation that we're dealing with. Now the time you might think is 10, but we got to be very careful. I'm going to give myself a little bit more space here. So I'm running out of room. Okay, even though it's 10 years, compounded quarterly. Quarterly means it happens 4 times a year. So to figure out our time, which is x in this case, we are going to do 10 years. Oh, not an x. Ooh, never an x for times. Oh my goodness, I'm breaking a cardinal rule of math here. Times those 4 quarters. So this is happening 40 times. So that's the value I'm going to be plugging in for x. I know, we started off with a beefy one, right? So 25,000 times 1.03 to the 40th. Now, the beautiful thing about your calculator is you can just slap this sucker in all at once. We love the calculator. It is our friend. It is our friend. It is our friend. Okay. And we are dealing with money. So because we are dealing with money, we are legally allowed to round to the 100th place. All right. So even though this goes past the 100th place, because it's money, we are allowed to round. So we get $81,550.94. I would like to go to this bank. That is some sweet, sweet money we have there. And I'm just writing it off to the side with my dollar sign because word problems need labels. Okay, like what does that represent? It represents cash money. So that is your answer. I know a lot was happening in that problem, right? Well, you take it apart piece by piece, use the cubes method. All right. So let's check out the next one. If you invested a penny, a cute little penny, on January 1st, 1776, good year for America, right? At a 10% interest, compounded daily. That's interesting. How much money would you have January 1st, 2011? And as I read this problem, like, were they even born yet? Anyway, who's feeling old? Anyway, okay. So I like to write our original equation, y equals ab to the x, where a is your growth rate, or excuse me, a is your initial, b is your growth rate. What are we starting with? A cute little penny. Cute little penny. That is our a value. Oop, my page is flying. 0.01 is a penny. Okay. Now our interest rate, our b value is going to be a little fun to calculate, similar to the last one. All right. So we have that 10%, but it is compounded daily. Now, assuming this is a normal year, we're not going to include leap years for the sake of this problem. So we are going to divide by 365 because there's 365 days in a year. Ooh, this is a gross decimal. So for me, I personally would love to leave it as a fraction, but it's gross as a fraction. So we're going to write out the decimal. It is what it is. We have 0.0000274. Blah. Now it's growth, right? Because we're investing money. We want to get more money out at the end. All right, so we're going to do that b value is 1 plus that gross decimal. And if it was decay, we would do 1 minus, but this is growth, okay? So we get 1.000274. Gross number, right? Okay, now how much time has elapsed? Well, if we take 2011 and subtract 1776, America, we get 235 years. But this is compounded daily. Daily. How many days are in a year? How many times is this initial penny being compounded over and over and over and over and over again? 365. So we have to do 235 years times that 365 days. So the number of times this penny was being compounded is 85,775. Blah. Gross. This is a gross equation. But hopefully we have a lot of money at the end. Hopefully your great grandmother or grandfather left you with some fun money. All right, so I'm going to write this equation in green because there's a lot of blue happening here. So we have that initial penny times our growth value of 1.000. This is so silly, 274. And we're raising it to the number of times it's been compounded, 85,775. Blah. Gross. All right. And remember, it's money, so we're allowed to round. Let's type this in our calculator. Oh my God. Are you seeing how big this number is? This is insane. I got to write it out first before I can say what it is. It's so much money. Somebody's forefathers found a great bank. Put in some commas. Over $160 million. That's bananas. That's pandemonium. That's trust funds. It's not my life. Anyway. Oop. Lots of moolah. So you can see how compound interest just snowballs so quick, right? We'll do another lesson on student loans at a later time. All right, let's check out one more. Ooh, this one's interesting. This one is asking, how much would you need to invest to get $20,000 in 5 years at an annual interest rate of 8.5% compounded monthly? So we're still using our y equals ab to the x, but in this case, we do not know our a value. Instead, it's saying, okay, our y value, what we end up with, we want to be $20,000. But we don't know our a value, but we do know our growth rate. So we have that 8.5%. So that as a decimal, 0.085 is compounded monthly. How many months are in a year? 12. And that will give us a fun decimal of 0.0070833. And investments, money is growing, right? So we're going to do 1 plus that value. So 1.0070833. So that is going to be our B value. Okay, but now what is our time going to be? So we have 5 years. Again, it's happening monthly. So how many times is that being compounded? So that's going to be 5 times 12. Me with the X's today. Oy vey. 60. So our exponent is going to be 60. So in this case, we have to solve to get A alone. And if you need some refresher on solving equations, go to the equations playlist. All right. So let's simplify the B value, the B to the X. All right, so we've got that 1.0070833 raised to the 60th. Blah, gross decimal, but I really don't like to round until the very end. All right. 1.527297565. And we've got to solve to get a alone. Well, a is being multiplied by that. How do we undo multiplication? We divide. So we're going to divide each side by that. I'm not going to write it out again. But we are dividing each side by it. I'll write it. I won't be lazy. I told you, in another video, I did say mathematicians, we're a little lazy, okay? That's like a lot of numbers to write out, okay? But I'll write it for you, just for you. They. All right. Gross. So 20,000. Don't add in an extra zero in your calculator like I just did. All right. And it's money, right? So that means we're allowed to round to the nearest hundredth. Woo! Okay. So that's going to be $13,095.03. About. Because we're rounding. Get that cash money in there. Word problems need labels. They need labels. All right. So if you did almost $13,100 as your initial investment, then after 5 years being compounded monthly at that 8.5% interest rate, you'd have about 20 grand. So yay, congratulations. Stick around for the next parts in this playlist. We're going to do some even more word problems. So have a great day. I hope you hate math just a little less. Bye.